How do subduction zones form Earth's deepest trenches? Imagine a giant puzzle where pieces of Earth's outer shell are constantly moving and fitting together. Some pieces are heavier and denser than others, and this difference creates incredible geological features. One of the most fascinating features is the deep ocean trenches, which are the deepest parts of our oceans. But how exactly do these trenches form? The answer lies in a process called subduction, a key part of how Earth's surface changes over time. Earth's outer layer is made up of large, rigid pieces called tectonic plates. These plates are always shifting, but very slowly, only a few centimeters each year. When two plates meet, they interact in different ways depending on what kind of crust they carry. Oceanic crust, which is mostly made of basalt, is denser and thinner than continental crust, which is mostly granite. When an oceanic plate collides with a continental plate, the denser oceanic crust is pushed beneath the lighter continental crust. This process is called subduction. The spot where this happens is called a subduction zone. As the oceanic plate is pulled downward into Earth's mantle, it creates a deep, narrow trench at the surface. These trenches are the deepest parts of the ocean, like the Mariana Trench, which is over 11 kilometers deep. The reason they are so deep is that the oceanic crust bends sharply downward as it sinks into the mantle. This bending forms a trench, and the deeper the plate goes, the deeper the trench becomes. The movement of the plates is driven by gravity and the Earth's internal heat. As the subducting plate sinks, it heats up and releases water trapped in its rocks. This water lowers the melting point of the surrounding mantle, causing magma to form. The magma rises toward the surface, leading to volcanic eruptions. That is why many volcanoes and volcanic island chains, like the Pacific Ring of Fire, are located near deep trenches. Subduction zones are also responsible for earthquakes. As one plate slides beneath another, it can cause intense shaking. Sometimes these earthquakes are powerful enough to trigger tsunamis, which can travel across entire oceans. These natural events reminded us how active and interconnected Earth's systems are. Over millions of years, the process of subduction recycles Earth's crust. Old crust is pulled into the mantle and destroyed, while new crust is created at mid-ocean ridges. This cycle keeps Earth's surface constantly changing. It also explains why some regions are prone to volcanic activity and earthquakes. So, next time you hear about a deep ocean trench or a volcanic eruption, remember that these features are the result of slow, steady movements of Earth's plates. Subduction is a vital process that shapes our planet, answers many questions about why certain parts of the ocean are so deep, and shows how Earth's surface is always in motion.